with a large diameter indicate faster action potential and thus influence neural conduction correlate the branches that can be found on the axon. An action potential is a brief chemical or electrical message that originate in the cell body and travel down axon potential travel down to action to the terminal button. When the axons split at the back end, they branch out widely, with each branch ending in a knob. Terminal buttons are what they are called. When an action potential travels down on action to the terminal button, a chemical substance known as neurotransmitter is released. Neurotransmitter can either be increase or decrease the activity of the receiving neuron through neuron are abundant in the brain. There are other primary cells known as neuroglia, glial cell, or glia that provide support to the neurotransmitter. Glia cell also influence thinking, learning, memory, perception, as well as assisting in nervous system homeostasis. The membrane potential is the difference in electrically charge across the membrane. The neuron is said to be resting when it is inactive, and it has a membrane potential of minus 70 MV or resting potential. Resting membrane potential is the term of this. The difference in potential is measured by in volt or millivolt MV. The principle of the principle the principle of the principle of the resting membrane potential RPM is used to keep RPM constant. Diffusion, electrostatic pressure, ion channel, sodium potassium pump, the nerve impulse travel from one cell from the cell body to the axon and finally to the terminal bottom. Membrane potential depolarize when a stimuli are the initiating region reaches the threshold of the excitator. This causes sodium ion to diffuse into the cell or move into the cell via electrostatic pressure. For a brief period, in the inside of the membrane become more positive in comparison to the outside, resting from minus 70 millivolt to plus 15 millivolt in about millisecond. The action potential electrically charged reversal at a specific point along with the axon reach its peaks. Potassium ion began to travel the cell body. No more sodium can enter it. The membrane potential returned to the its resting state. Because of this, the action potential is an all or nothing phenomenon, meaning that it can either goes down the axon to its terminal bottom or does not happen at all. As a result, information is sent axon via action potential, which are small electrical pressure. The amplitude or size of the nerve impulse is determined by the type of neuron and the rate at which it conducts impulses. The depolarization of the membrane occur when potassium ion begin to travel the cell. The membrane returns to its resting state once enough positively charged potassium ion have released from the cell. When the cell loses too many potassium ion, the membrane becomes slightly hypolarized, but the potassium channel close, allowing the membrane potential to return to its normal resting state. Thank you for watching my YouTube channel. Thank you.